Einstein refused to believe it until his dying day, that the universe doesn't exist unless you look at it. What's even crazier is the deeper you dig into it with physics, the more you find it's not one problem but a whole chain of them. Like, does a thing even have real properties before you measure it? Is space just a static backdrop or a structure that grew later? Does time really flow, or is it just an illusion at our scale? If the quantum rules are the ultimate bottom layer, then how much weight does the word real even hold anymore? For most of history actually, we pictured reality as pretty straightforward. Things just sit there on their own like a rock. Whether you look at it or not, it's right there, not moving. Switch to a chair, same deal. You're not looking, it doesn't suddenly turn into something else. We took that feeling as the default setting. Reality should be stable, measurable, and totally independent of you looking at it. Classical physics was built entirely on this setup, and we always believed the world was made of objects with definite properties. We just had to figure out the laws they followed. And this picture really worked for a long time. It let us calculate planetary orbits, build engines, power grids, master chemistry, even get satellite positioning and rockets off the ground. But the deeper we looked, the less it matched what we actually measured. Quantum mechanics didn't just tweak the rules, it flipped our deepest intuition about reality on its head. It's not saying reality is just elusive or spooky. It's saying that certainty you think reality must have might not be something the universe is required to give you. But here's the thing, if certainty isn't standard, then the table we touch every day, the traffic light we see, the phone screen we scroll, why are they so stable? Are they stable by nature, or does the world snap into stability only when you reach out and force it to? Let's not get philosophical, I'll give you direct evidence. Because physics in the lab has done something particularly brutal. It turned the act of looking or not into a repeatable, measurable result. Once you understand this next cut, you'll see the world's certainty might not be a free gift. It's more like something you have to pay a price to get. The most classic cut is the double slit. Imagine a wall with two extremely thin slits in it. You fire the most straightforward thing at it, say an electron. Intuition says it has to pick one, left slit or right slit. But if you don't ask which path it took, what hits the screen isn't two clusters of dots, but a wave-like interference pattern of stripes. This feels deeply wrong because it implies it didn't pick one path to get there. It's more like it took both into account. Here's the kicker. Fire electrons one by one, a single particle at a time. Each landing spot seems totally random. You might think it's just noise, but let them slowly pile up over time, and that statistical pattern of stripes still emerges. It's like the universe is reminding you, can't make sense of a single event, that's fine, but the grand total, the final tally, the rule was written there all along. But change just one thing. Say you want to know which slit it actually went through. Put a detector at the slits. Note, you don't need to knock it away or heat it up. You just make it possible for path information to be recorded. The picture changes instantly. The interference stripes vanish completely, leaving just two clusters of dots, like bullets, like the electron finally picked a side and behaved. The stinger isn't just what you see. The real stinger is, you don't even have to look at the record. If the information exists, if it can in principle be known, the stripes are gone. It's like the universe says, you want certainty, fine, but certainty has a price, you pay the price. The world gives you a more well-behaved answer. You don't pay. The world withholds that comfortable certainty. So let me put it even more bluntly now. Reality doesn't exist because you look. Reality is more like this: once you demand an answer, it's forced to collapse into one particular version. You demand the path, you must give up interference. You demand interference, you must give up the path. You want both. The universe just says no. So the question is, why not? What or who is stopping you? Don't think of it as some mystical force watching you. The most brutal point in quantum theory is this: it doesn't need you to look. It only cares about one thing. Has path information left a trace in the world? If a trace is left, even if you never read it, even if you smash the hard drive, the interference doesn't come back, because the decisive step already happened. So what does measurement actually do? It isn't discovering the particle's path. It's more like manufacturing a path. You measure and the particle is forced to interact with the detector. That interaction happens, and the particle is no longer an independent thing. It's entangled with the detector. And in the next instant, the detector is entangled with the surrounding air, thermal noise, the electromagnetic field. You think you just placed an instrument, but you actually dragged a microscopic system into a massive environment. Think of it like two lines drawn on a clean sheet of paper. As long as the paper is pristine, the two lines can overlap and interfere, creating that striped pattern. But the moment you touch the paper, even lightly, you leave a fingerprint. The fingerprint doesn't need you to stare at it, it's just there. From that moment on, the two paths are marked by the environment. They can no longer superimpose. They can no longer interfere. The stripes die, not because you saw them, but because the world already took note. This is the most counterintuitive part of measurement. We used to think measurement was a readout. Now it looks more like a write-in. The way you ask the question becomes part of the system. You ask for path information. The system writes that information into existence for you. But once it's written, the possibilities that could have overlapped get snipped apart like with scissors. They become two mutually exclusive stories. You still get an answer, of course, but it's an answer that's now nailed down. This also clears up a common misunderstanding. Many people say, oh, that's just the instrument disturbing it. You touch it, of course it changes. But the point is, what's fatal in the quantum world isn't the size of the energy exchange, it's whether information leaks out. You can make the disturbance incredibly tiny, so small it barely transfers any energy. You can even design measurements that are just a gentle tap. But if the path information can be preserved, interference is still gone. It's like the universe emphasizes, the key isn't force, it's distinguishability. Can you tell the two paths apart? If you can, interference has no right to appear. So look back at that interference pattern now. It's actually saying something outrageous. As long as two paths are in principle indistinguishable, they happen together as if they were the same event. But the moment you make them distinguishable, even if you don't read the data, even if you pretend it didn't happen, the world immediately changes its tune. Fine, we'll treat them as two separate, unrelated paths. You want both. The universe says no. Essentially, you want the interference that comes from indistinguishability, and also the definitive path answer that comes from distinguishability. You can only buy one of these two tickets. At this point, reality starts to look like a transaction. Every question you ask costs you something. The more specific your question, the more well-behaved the answer the world gives you. But you're also sacrificing another possibility in the process. You think you're closing in on the truth, but you're also personally shutting down another version of it. Quantum theory isn't playing mystical games with you, it's giving you a price list. But what's even more unsettling is this price list doesn't just affect how particles move, it starts to mess with our gut feeling about time itself. Because if you push the question to an even more extreme form, you'll find the very notion of sequence might not be as solid as you thought. Your intuition says it's simple, right? Particle goes through the slit, then gets measured, then hits the screen. The order is hard and fixed. But some experiments specifically tell you order might not be decided by time, but by information. You can even let the particle finish its journey and then decide later whether or not to keep the path information. It sounds like you're changing the past, but a more accurate way to say it is, you're deciding whether the past gets written as a single definite story. The most brutal version of this experiment makes keeping or erasing the path information a button you press at the very end. You let the particle go through the setup first. Its journey is already over. It has already happened in some sense. Then you make your choice afterwards. Do you keep the path information or not? If you keep it, the interference vanishes as if it never could have happened. If you erase the path information, the interference suddenly comes back to life. You instinctively shiver, because this seems to say, a choice in the present decides how the past is presented. But the key here isn't that you're rewriting events that already happened. The key is that in quantum mechanics something happening doesn't equal having a single definite history you can tell. For history to solidify, to earn its narrative right, it must satisfy one condition. Can information distinguish the story from others? You preserve the path information. History is forced to become two mutually exclusive routes. You erase the path information. History loses the right to be split into two routes, so the interference returns. You think you're manipulating time. You're actually manipulating which versions of the past are allowed to be defined. So you see, the trouble really isn't one thing but a whole chain. We started with properties and found they might not have fixed answers before measurement. We dug into measurement and found it's not a readout. It's a write-in. It's making the environment remember. Now we go one layer deeper and find even the sequence of events might depend on information. The three things you thought were rock solid, properties, spacetime, are all starting to wobble. If you want to save your classical intuition though, you can still fight back a little. You could say, there must be hidden variables. Deeper down, the answer was already written, we just can't see it yet. But the next step pushes that hope right into a corner. Because physics doesn't just tell stories, it set a testable trap. Step into it, and you have to pick a side. So how do you step into this trap? Simple: take your belief about reality and break it down into two non-negotiable premises. 1. The outcome was already written, measurement just reveals it. 2 things far apart can't influence each other instantly. Information can't jump across space faster than light. If you insist on having both, then correlations must have a strict upper limit. They can't exceed it. But here's the problem. Experiments blow right past that limit. Not by a little, but by a lot. The method isn't fancy. Entangle two particles, separate them far apart. Measure one here, measure the other there. Intuition says they can at best be like they pre-agreed on a code. Align a little, but there has to be a cap. The data tells you the alignment is stronger than any possible cap, as if someone tore up the rulebook. What cuts even deeper? This isn't a one-time fluke. Change the apparatus, still over the line. Change the distance, still over the line. Change the measurement angle, still over the line. The more you try to blame experimental error, the less it holds up. Finally, you have to admit, it's not the experiment that's weird, it's your set of intuitions. At least one piece of it is breaking down. So from this moment on, stop fantasizing about having it all. The things you most want to keep simultaneously probably can't coexist. You want answers written in advance. You want distance to be an absolute barrier. You also want to be completely free in how you choose to measure. But reality forces you to admit you must let go of at least one. You can refuse to let go, but the results will force your hand. So which one do you drop? How do you rebuild a coherent logic? This is where interpretations step onto the stage. Some choose to loosen the answers written in advance premise first, because once you loosen that, the double slit makes immediate sense. You preserve path information, superposition gets cut, interference dies. You want certainty, you pay with possibility. Meaning the world isn't inherently well behaved, it's forced to behave by your actions. Others flip it around, preferring to drop the distance as absolute barrier rule. Because the correlation strength and entanglement is just too unreasonable. It's not like two independent objects living separate lives far apart. It's more like two pages of the same ledger. You flip one page and the other must align. Not because a message was sent, but because they were never separate to begin with. Some go even further, starting to doubt that your so-called free choice is as clean as you think. You think you're twisting a dial on the spot, but maybe at a deeper level. You and that particle pair were always connected by the same causal web. You feel like you're choosing, but you're just arriving at a fork that already existed. This idea is jarring because it challenges not physics details, but your own most comfortable sense of certainty. See, this is the truly annoying thing about quantum theory. It doesn't just give you a new term and call it a day. It forces you to put down a deposit. You want a coherent worldview, fine, but you must mortgage one of your intuitions. Which intuition you mortgage determines the entire explanatory framework that follows. But humanity can't stay stuck on a multiple-choice question forever. We have to find a path forward. So a few different approaches have emerged in science. One camp is ruthlessly pragmatic, they narrow the question. If the underlying picture is murky, don't talk about it. Just write down the rules, calculate the probabilities and test them with experiments. What it is before measurement isn't guaranteed to be explainable, but once you measure how the results will distribute, it can calculate accurately. It's cold, but it works so well that modern technology runs on it. Another camp can't accept that coldness. They say no collapse, no cutting. All possibilities are always happening. You seeing one outcome isn't the world picking an answer. It's you and the world branching into one version of reality together. The other branches are just as real, you just can't go there. It's logically clean, but the cost is high. You must accept a universe vastly larger than you imagined. Another camp is more realist. They say don't treat collapse as a mysterious instant. What really pins things down is the environment. The microscopic can be in superposition, but the macroscopic world is too noisy. So noisy that once information leaks out, superposition can't survive. What you perceive is stability. Not because the universe is inherently stable, but because the environment forces it into stability for you. When you get down to it, we're going in circles because we're really just admitting one thing. Quantum theory isn't denying reality. It's denying our old checklist for what reality should be. We used to assume reality must be definite, independent, pre-written, like a rock sitting there waiting for you. Now it seems the universe may have never agreed to those terms. It seems layered. A bottom layer of possibilities and information, and an upper layer of the definite world you can touch. The table you touch every day is certainly real, but it's more like a stable compressed version shaped by its environment, not a photo of the raw bottom layer state. And one point must be hammered home or you'll be led astray. What decides all this isn't what you think in your mind, it's not consciousness creating reality. What truly matters is whether information leaves a trace, whether it gets recorded, whether it becomes distinguishable. The moment you let information leak out from a system, the world is forced to shrink into a single tellable version. You want an answer, you pay the price. So certainty isn't a freebie, it's more like a transaction. Finally, I'll throw the question right back at you. That rock-solid feeling of certainty you take for granted every day might not be the universe's default state, but a survival-friendly version the universe grants to macroscopic life. Don't ask too harshly and it lets you live in stability. Ask all the way to the bottom and it flips open the ledger, showing you the fine print behind certainty. So I'll ask you two final questions, no hedging. Which one are you more willing to believe? That the world's answers were written long ago and we're just discovering them? Or that the world is a set of possibilities that only hand in an answer when you force it to? And harder, if you must sacrifice one gut assumption, which would you give up? Answers are pre-written. Distance isolates everything, or your own sense of free choice. Explain your reasons in the comments. Because the truly frightening part of this question is right here. Whichever side you pick, it's going to sting.